Hi guys, in our first video we had looked at the simpler form of trying to apply this concept of integration by parts, and we had mentioned that you can be able to apply a formula of the integral of this specific function ud v is equivalent to uv minus the integral of v du, which is going to be applicable for of course integrals which are going to be using this specific technique of integration by parts. So we are going to apply this specific approach in trying to solve our integral that I've given on the board, whereby we're going to, we had said that we're going to let dv be the most complicated portion of the integrand that is going to fit into the basic integration formula, and therefore u is going to form the remaining part. So therefore it will be pertinent for us to identify which section of this specific integral is going to be u. So for me, I'm going to choose let u be represented by x squared. So therefore, in this specific case, we can be able to do the integral, or rather the derivative of du over dx is going to be equivalent to 2x, implying that du is equivalent to 2x dx given as such. So therefore, we have found our derivative of this specific function for du, our representation for du, that is going to be given as 2x 2x dx. So therefore, if we have said that let u be x, and the dv that I've mentioned therefore is going to be represented by a rather complicated section of this, or a complicated section or portion of this specific integral, and therefore my v is going to be obtained from this, whereby we're going to find that for exponential functions, the v is going to be ex given as such. So for me, I'm going to just do a direct application of this specific function, whereby I'm going to write it as the integral of x squared ex, therefore dx can be represented as u. My u in this case, for me, is going to be represented as x squared, given as such. And then v is going to be represented using ex, as I've mentioned in this specific, as I've indicated in this particular section. And then minus the integral of v. So my v is ex, and then du is going to be represented by 2x dx given as such. So therefore, if we try to look at this, then therefore we're going to have a second portion of this specific integral giving us another integral form, which we as well need to solve using the same approach as we apply for the first one in this case. So this is going to be, I'm just going to assume the first part so that we do a negative integral of this specific function. So therefore, we're going to have this one as the integral of ex 2x dx. And this is going to be given as the integral of, or rather the integral of 2 ex, the integral of x dx are given as such. Or we can just still do a rearrangement and have it as the integral of 2x dx, just for simplicity purposes. So therefore, for this one, I'm going to choose the various parts for u and v. Now, for this constant, we have talked about the constant, multiple constant rule, and therefore it's going to be taken out of this. So therefore, I'm going to say let u be represented by x. So du over dx is equivalent to 1. So this one implies that the du is going to be equivalent to dx, as we have done for the first case. So therefore, this is going to be given as to the integral of this specific part, which is x ex, and then we're going to have it dx being given as. So if we try to look at this, then therefore if we do a direct substitution for this formula, we are going to have 2 as a common factor, which is a constant multiple being taken out. And then my u is going to be the x that I've given at this specific part. So I'm going to have x. And then my v is going to be represented. So in this case, the difficult, or rather the rather complicated portion is going to be represented by the exponent of x, which is going to be given as ex as such. So therefore, my v is going to be represented by ex, minus the integral of v. Now, in this case, v is going to be represented as ex as I've said, and then du, which I've said that this specific aspect for du is going to be equivalent to dx, given as such. So in trying to solve this one, I'm going to have it as 2 into x ex, and then minus the integral of this one is going to be ex, and then this is going to be given as plus c, but I'm going to give it as that specific point. So in this case, as I've said, we have left the first portion of this specific integral. So this is going to be a whole negative sign being given as such. So therefore, if we try to do a substitution for this second part, we are going to have the answer for this integral being given as ex, and then x squared ex, and then we are going to have this minus 2x ex, which is a second, the first portion of this specific part, which is in brackets. And then because of this negative sign and this one, this is going to be the plus ex. And of course, there's this 2, the factor of 2 that is here, so it is plus 2ex, and then we are going to have this one plus c. So this one implies that whenever we are given an integral of this specific nature, we'll first perform the first differentiation by, integration by parts to obtain the first section, which is, of course, this specific part. And for the second section of the integral, which is going to also apply the same procedure, then therefore we are going to perform this specific aspect, which we are going to do at this specific point, and then try to combine the two answers together to find the overall integral for our expression that, or integral that we have given on this first part. So I hope that this, together with the first video we are done on the same, is going to create a comprehensive way of trying to understand this specific approach of integration by parts. So catch us in our next video, guys, as we discuss on different areas related to the same, and check on our description boxes of our various videos which are similar to this, so that we can assist one another in trying to attain more skills in this specific subject. So that is it for now. Bye, guys. God bless you.